Hello, welcome to a lesson on triangle congruence by side, 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 abbreviation SSS. In the previous lesson, look at the diagram here. We learned that two triangles are congruent if all of the corresponding parts are congruent. There's three angles and three sides. That's a total of 6 pieces of information that we're looking for. And once we know all 6 are the same, we can say, yeah, they're the same. Well, what if it were a little bit easier to make sure that two things are the same? If I was designing something, maybe you look back at some of the ancient buildings that were created. How could we use geometries to shortcut to find a quicker way to determine if two things are congruent? So this is where this theorem comes into play. Look at these two triangles here. Notice that their markings are only dealing with the sides. All 3 sides have a marking so that the two triangles share equivalent lengths on the 3 sides. Does that mean that there's only one way to make the triangle? The answer is yeah, there is only one way to make the triangle. If this had a length of 3, and this had a length of 3, this had a length of 4, this had a length of 4, this had a length of 5, and a length of 5, then you could determine that there's only one way to build those triangles. GeoGebra is a great way to examine that. I'm going to come up with 3 lengths. You could do this with cutting out pieces of string. You could cut straws at your house and determine if this is true. But let's say we had a length. One of the lengths was 2 inches. Let's say a second piece of a straw or string was cut that it was 3 inches. And then the third piece of straw, let's say it was 4 inches. All right. Could you put those 3 straws together to make a triangle? And if the answer is yes, can you make more than one? Let's examine it with GeoGebra. 2, 3, 4. So here I have a grid, and I've set it up so that these squares are just inches apart, or they would represent an inch. So if I put points there's a point. I'm going to build a circle. I'm going to build a segment that is too long. So let's put a second one there. And then I want to build another segment 3 and 4. Now the problem is if I go straight up or straight down, it may not work. Let me show you what I mean by that. If I go straight up 3, that's a distance of 3, then how in the world do I know if that distance is 4? It's probably not 4. In fact, if I were to check it, I can check it by turning on the label. Okay, turn on the label, and I want to find the value of it. Actually, it turns out it's 3.6. That's not what I want at all. Okay, that's not going to work. So how do I use GeoGebra to construct it? Well, once I have this one set at 2, I can put that there. That's good. Okay, I know that one. In fact, let me turn on all the values so we can see this is true. All right. Then what I want to do is I want to build a circle with a certain radius. So I'm going to click more. I'm going to go down to circle, center, and radius. At A, I'm going to click a circle there, put radius 3. Okay. And then at B, I'm going to put a circle with radius 4. Okay. Notice there's an overlap. Notice that they touch. In fact, at 2 points, you can create a triangle by finding that intersection. So let me click more, go to my points, and intersect where these 2 circles intersect. Now, what you've basically done is created a polygon. Let me connect A, B, and C into a triangle such that the sides have lengths 2, 3, 4. Now, how do we know this? Well, I can turn on the feature and show you, but the reason we know is because the distance from A to C is a radius of a circle of radius 3, and the distance from B to C is on a circle with radius 4. I set it up that way or constructed it that way. And there's really no other, let me click on these really quickly. There's no other way to get a different triangle. Let me show you these labels just really quickly. I have an email coming in there. I can see that's kind of getting in my way. That's all right. Okay, that one's 3. And then let's click on this other one, show its label, and it has a value of 4. You can see that that's the case there. And this is cool. It's dynamic in the way that it works. Okay, I can move these around, but it maintains its relationship. Oh, actually, it has to stay there because it's at 2. Now, there is a secondary point where they intersect down here, but that would in essence form the same triangle. So what we learn is there's one and only one way to build a triangle with the values 2, 3, and 4 as side lengths.